Hello everyone. Today we'll talk about this question that came in GATE 2023 Biotechnology paper. An enzyme catalyzes the biochemical reaction A to B with kcat equal to 500 second inverse. If the initial reaction velocity V0 is 10 micromolar second inverse at the total enzyme concentration of 30 nanomolar and substrate concentration A of 40 micromolar, the value of Km in micromolar is. So we'll talk a little bit about the concept of Michaelis-Menten and how that Michaelis-Menten equation can be utilized to solve this question. Then we'll move on to solving this question. The most important factor in questions like this, sums like this, is the unit. So there are two units for concentration used, micromolar and nanomolar, but the answer is required in micromolar. So it is always advised to check properly the unit in which the answer is to be written, because that decides the correctness of the answer. Now let's talk a little bit about the features of enzyme catalyzed reactions. So the principal features are as follows. Like for a given initial concentration of substrate, the initial rate of product formation will be proportional to the total concentration of enzyme. For a given enzyme and low values of substrate will be the rate limiting factor and the rate of product formation is proportional to substrate. For a given enzyme concentration and high values of substrate, the rate of product formation will become independent of substrate concentration, then that will reach a maximum value known as the maximum velocity or Vmax. About the Michaelis-Menten hypothesis, this was invented by Michaelis and Menten, and according to this mechanism, an enzyme substrate complex is formed in the first step and either the substrate is released unchanged or after modification to form products. So the Michaelis-Menten equation is basically the rate equation for a one substrate enzyme catalyzed reaction, and it is a statement of the quantitative relationship between the initial velocity, the maximum velocity and the initial substrate concentration, all related to the Michaelis constant or Km. So this is the value or the equation of Michaelis-Menten equation. So this numerical relationship emerges from the Michaelis-Menten equation, and in the special case when the initial velocity is exactly 1/2 of Vmax, in that case if we solve for Km, we will see that Km becomes equal to substrate. So Km is equal to the substrate concentration when V0 or initial velocity is half of maximum velocity. Now what is Km? Km is basically the substrate concentration required to reach half maximal velocity. As we found from here only, we can see that this is the significance of Km. So Km is basically a measure of a substrate's affinity for the enzyme. A small Km will mean that the substrate binds tightly to the enzyme and saturates the enzyme. So this is the Michaelis-Menten curve. On the x-axis we have substrate concentration, on the y-axis we have initial velocity, and this is the curve. Eventually it reaches Vmax. Now what is Vmax? So considering the total enzyme concentration, the maximal rate that the enzyme can attain will be its maximum velocity or Vmax. Now Vmax is equal to the product of the catalytic rate constant kcat and the concentration of the enzyme. This is the property that we'll use to solve the question that we talked about. Okay. So Vmax is equal to kcat into the concentration of the enzyme. So the Michaelis-Menten equation can also be written as V0 equal to kcat enzyme into S by Km plus S. Basically we are replacing Vmax with kcat enzyme. Okay. So the higher the kcat value, the more substrates get turned over in 1 second. Okay. So this graph shows the Michaelis-Menten kinetics, the kinetic parameters that define the limits of the curve at the high and the low substrate concentration. So at low substrate concentration, Km will be very much higher than substrate concentration, and the substrate term in the denominator of the Michaelis-Menten equation becomes insignificant. So the equation simplifies to V0 equal to Vmax S by Km, and then V0 tends to exhibit a linear dependence on S as observed here. At very high concentration of substrate, where substrate concentration becomes very much higher than Km, the Km term in the denominator of the Michaelis-Menten equation will become insignificant and the equation will simplify to V0 equal to Vmax, and this is consistent with the plateau observed at higher concentrations of substrate. Okay, so the Michaelis-Menten equation is therefore consistent with the observed dependence of initial velocity on substrate, and the shape of the curve is defined by the terms Vmax by Km at low substrate concentration and Vmax at higher substrate concentration. Okay, so The Michaelis-Menten equation can also be algebraically transformed into equations that are more useful in plotting experimental data. For example, the Line-Weaverberg model. So we take the Line-Weaverberg model is basically the double reciprocal of the Michaelis-Menten equation. So in this case, 1 by V naught, Km by Vmax, 1 by S plus 1 by Vmax. So the equation, the Line-Weaverberg equation is of a straight line. The equation of a straight line is y equal to mx plus c. So this equation also takes the form of a straight line. Okay, and this is the Line-Weaverberg or the double reciprocal plot of if we take the Michaelis-Menten and do the double reciprocal plot, that will give us a Line-Weaverberg equation. And Line-Weaverberg plot has the great advantage of allowing a more accurate determination of Vmax, which can only be approximated from a simple plot of V naught versus S, substrate concentration. So the double reciprocal plot is very useful in distinguishing between certain types of enzymatic reaction mechanisms. Now moving on to our question. Our question talked about the enzymatic reaction of transforming A to B. The kcat value was 500 second inverse. The initial velocity was 10 micromolar per second. The enzyme concentration was 30 nanomolar. The substrate concentration of A was 40 micromolar. What was the value of Km in micromolar? So if you want to find the value of Vmax, then Vmax equal to kcat into enzyme concentration, that we already discussed. So kcat is 500 second inverse and enzyme concentration is 30 nanomolar. Now we'll change this 30 nanomolar into micromolar because the answer that is required is in micromolar. So if we convert 30 nanomolar to micromolar, that becomes 30 into 10 to the power minus 3. So the value of Vmax comes to 15 micromolar per second. Okay, this is the first step of the sum. In the second step, we'll follow Michaelis-Menten equation. So V naught equal to Vmax S plus K by Km plus S. Vmax is 15. Substrate concentration we know is 40 micromolar. The substrate concentration is given in micromolar, so we don't have to change anything. Now we have to find Km. So in this equation, if we look for Km, the value of Km comes to be 20 micromolar. Okay. So Michaelis-Menten equation is a very important part of enzyme kinetics. We need to remember what these terms signify. V naught is initial velocity, Vmax is maximum velocity, S is initial substrate concentration, and Km is the Michaelis constant. Okay, so the answer comes to be 20 micromolar. So in this question, the value of Km in micromolar will be 20. Okay. If you want to learn more about enzyme kinetics and these kind of sums, Michaelis-Menten, Line-Weaverberg model, then I suggest you go through this course, Biochemistry by Professor K. Subramaniam. It's an NPTEL course and there are 3 YouTube videos already uploaded that you can also refer to. Thank you.